a little review on rolling projectiles. What I call rolling projectiles are things that leave wherever they are purely horizontally, and then they start to follow the projectile path, right? And so that's what a rolling projectile for me is. That's what I call a rolling projectile. And what that means is that the second they become a freely falling object right here, right? Here's where we would place our origin. The second they become a freely falling object, they are moving only horizontally, right? At this point, at the beginning of our motion, they have a Vxi, and that's it, right? Because if it's moving purely horizontally at this point, Vyi is equal to 0, right? Its velocity at that point is purely horizontal. So that means we would be given some number, right? Or we would know our Vxi, but our Vyi, we have to know is 0 for rolling projectiles. And we know that just based on the context clues. So we've got to read our problem really carefully, right? We've got to be able to read our problem. And when it says it is thrown horizontally from a cliff, that tells us that the velocity that we're given is going to be horizontal velocity only. It will have no vertical component. Okay, so let's go ahead and start looking at this next problem here, right? Reading our problem really, really carefully here. It says a rock is thrown horizontally from a cliff that is 24 meters high. So I'm going to go ahead and draw a little diagram here of my problem, right? It can be very simple, but we've got to read our clues really carefully. Okay, a rock is thrown horizontally from the top of a cliff that's 24 meters high with a horizontal velocity of 3.21 meters per second. So this velocity, tell me what variable. Tell me exactly what variable does that go with. That's not a variable. I need an exact Vx something, Vy something, V or Xf. Is it time? What is this variable? Yes, very good. Vxi, right? Meters per second tells me its velocity. And look, right here, doesn't it tell me its horizontal velocity? Right? It tells me that not only right here, but it also tells me it is thrown horizontally. We've got to be really, really diligent about when we read these problems using the context clues to give us that information. So Vxi is equal to 3.21, which means what does Vyi equal? No. What did we just say about this? If it's thrown horizontally, what does Vyi have to be? It has to be 0. When it leaves the cliff, it is only moving horizontally. It would be like I saying he's got a velocity of 3.21 meters per second east, right? If my velocity was 3.21 meters per second east, does it have a y component? No. That's the same thing that we're talking about here. Okay. Second thing we always know is that my initial displacements, right? Let's draw the origin here so we know my origin is right here at the beginning of my motion. That means that my initial displacements, y, I, and xi are always what? Always 0, right? The starting points of my motion are always 0. Okay? We've got one other piece of information from the problem that we still need to assign a variable to. What does that 24 tell us?
Final displacement.
Final displacement, good, but does it tell me vertical displacement or horizontal displacement? Vertical. So that means YF, is it going to be positive 24 or negative 24? Negative, because it is going to land 24 meters below where it started, right? My rock is going to land right down here. Okay, so if my origin, if this is my x-axis right here, and this is my y-axis, this object is going to land with some positive x and some negative y value. right? Do we see how it sits there on a coordinate map? Does the same thing, okay? So it asks me for how long is the rock in the air, and then it asks me a couple other questions here. So I'm going to go ahead and click through those so that we have it. But I know on your slides it asks you a couple other questions, right? How far from the base, and what's the final vertical velocity? So I'm going to go ahead and put that writing back on there. Okay. All right, it's kind of hard for me to read that, but okay. My VXI and my VYI. Put those back in there. VXI equals 3.21, VYI equals 0, Y initial is 0, X initial is 0. Okay, so if we want to solve for time, we need to solve for how far from the base. What does that mean? That's this value right here. And so what variable does that go with? X, final. Very good. That's my next question mark. And then final vertical velocity. How would I write out that variable that I'm looking for? Final vertical velocity. Perfect. Yep, perfect. VYF would be my next question mark. Okay, so we need to kind of choose an order to solve for these, right? I would go ahead and solve for time first, but it doesn't really make a difference which one we solve for first. I'm going to go ahead and go in this order and solve for time first. So I've got to take a look at my projectile equations, right? Pull out your equation sheet and look at your projectile equations specifically. Okay, so if we look at our equation sheet, I agree that second vertical equation, y final equals y initial, right? We go all the way. That equation, we're going to use that to solve for time a lot, right? And we don't need the quadratic here because my VYI is 0. So let's go ahead and set that up. Okay, to solve for time, I'm going to take y final, which is negative 24. Negative 24 equals y initial, which is 0, plus VYI, which is 0. Plus 1/2 a. What's my a? What's my acceleration in the vertical direction? Negative 9.8, good, and t squared. Okay, so we need to now solve for t. Okay, so go ahead and do that. Go ahead and solve that equation for t. So we've got the amount of time. That's the total time that our rock is in the air, okay? Now I want to know how far away from the base does it land. So I've got to solve for x final. So let's look at the equation to solve for x final. I think we only have one equation that even allows us to solve for x final. Would you agree? So I'm going to say x final equals x initial plus v xi times time. Make sure we're putting the correct units there on our answer, right? If we're solving for displacement, our unit should be meters. Do we agree with that so far? Okay, and then the last thing it asks me for is final vertical velocity. So VYF, I need to choose an equation to help me solve for VYF. So I can pick either my first equation or my third. Yeah, you can pick either one. It makes no difference, right? We've got the time. We've got the final vertical displacements. You can choose either one. So I'll just choose the first because it's the simpler one. VYF equals VYI, which is 0, plus A times time. And my VYF comes out negative. Does that make sense? Does that seem reasonable that it would come out negative? Yeah, because it's going down, right? It's going in the negative direction. Okay, tell me, what questions do we have about this problem? Right, this problem asked us to kind of run the whole gamut of things we could solve for, right? We needed to find the time and the final displacement and the final vertical velocity. What would you say if I asked you for the final horizontal velocity? What would VXF be equal to? If I asked you for the final horizontal velocity, what would you tell me?
0?
Nope, not 0. It would be 3.21, right? If I asked you for VXF, it would be the same as my initial horizontal velocity, right? Because our horizontal velocity is unchanging throughout the entire problem, right? It is not changing. There is no speeding up or slowing down in the horizontal direction at all. So my final horizontal velocity would be equal to my initial horizontal velocity. That's not a question that you really ever get, but I want you to be thinking about what that. All right, let's try this one together, and then I'm going to write up a couple extra on your own. Okay, so it says a diver running 4 meters per second dives out horizontally from the edge of the cliff and 2.2 seconds later hits the water. How high was the cliff and how far from the base did it land? Okay, so again, I'm going to encourage you to draw just a simple diagram with this motion, right? Here's my cliff. My diver's running horizontally and he dives out horizontally. That is a clue for us that it is a rolling projectile, okay? That my velocity that's given is my initial horizontal velocity. So 4.0 meters per second has to be equal to VXI. And so if my 4.0 meters per second is all horizontal, what does that mean about VYI? It's 0. Okay, we've got to be able to pick up that clue from reading the problem. Okay? It says my cliff, I don't know how high it is, and I don't know how far away he's going to land. Right? Those are the two things that it's asking me to solve. But it does give me one other piece of information. 2.2 seconds is equal to my time. Okay, so let's write out what are our question marks here. How high was the cliff? What does that mean I'll be solving for? Nope. Is X horizontal or vertical? So Y final. And then how far from the base did it land would be XF. All right, so it doesn't really make a difference to us what order we solve these in, okay? Y final, you really only have one option as to what equation you can use based on the information you're given. You've only got one option. Do you know which one it is? Out of your vertical equations, I think only one of them will work. Have to use the second one. So Y final equals Y initial plus VYI times T plus 1/2 A T squared. Our Y final comes out negative here, which I would agree with, right? Because our object is going to land 23.7 meters below where it started. Would we agree with that? Right? If here's our origin, our object is going to land 23.7 meters below where it started. But to answer the question, how high was the cliff? How should I answer that with a negative, or should I just make it positive? I can just make it positive, right? So to answer how high was my cliff, I'm going to say the cliff was 23.7 meters high, right? This is one of the few areas and one of the few exceptions where I would accept a negative. Like if you just told me there, that's my Wi-Fi now, I would probably accept that. But I want you to understand that the reality of the answer, right? The question is actually asking how high the cliff is. So that is a technically a little bit better answer, right? Turning it around to make it positive is a little bit better of an answer. Okay, a little bit better option. Okay, so that's part one of our question. The next one asks, how far from the base did it land? So I want you to find out we only have one equation that helps us solve for my final displacement, x final. So I'm going to take x initial, which is always 0, plus vxi times time. Okay, so 4.0 times 2.2 gives me a final displacement of 8.8. And what would my units be on that one? For final horizontal displacement, what would my units be? Meters, right? So I want to make sure I put meters on there as well. Did you notice how this problem, the time was really similar to the last problem? In the last problem, our cliff was 24 meters high, right? We were right in that same ballpark. We need to make sure we understand that horizontal and vertical, right? They don't have anything to do with one another. So anything that's dropped from a height of 24-ish meters is going to take about 2.2 seconds to hit the ground, right? It doesn't matter if it's moving horizontally or not, okay? Because we're going to analyze horizontal and vertical motion separately. Okay, I want to try one more here. I'm going to give you a problem that's not in your notes. So you can either write it to the side. You can pull out a separate sheet of scratch paper if you want. But I'm just going to put another problem up here on the board for you to work on your own. Okay, so let's try this one on our own. Okay, so it says a ball is kicked horizontally off a cliff that's 32 meters high. If the ball lands 16 meters away from the base, how fast was it kicked? I need to add one more piece of information. It was in, actually, hold on here just 1 second. It was in the air for, actually, never mind. You can solve that.